This is May 2015, paper 2, time zone 1, question 4, and it's a question about rational functions. We've got f of x is equal to 2x minus 6 over 1 minus x. X is not equal to 1. Fine, we're going to think about the graph and we're going to find the x-intercept. X-intercept means that the y value is equal to 0. So we've got 2x minus 6 over 1 minus x equals 0. Well, that's only ever true if the numerator is 0. The only way you can get a division that gives you the answer 0 is if the numerator is 0. So we're really just solving the equation 2x minus 6 is 0, and you can probably do that in your head, but just to formally go through the steps, we get 2x is equal to 6, which means x is equal to 3, is our x-intercept. Part 2, write down the equation of the vertical asymptote. So write down tells you that you don't need to do any calculation. You should just be able to look at this equation, this function, and maybe with that piece of information work out what the vertical asymptote is. The vertical asymptote are lines where the function is not defined. When you sketch your function, whatever it looks like, if you've got a vertical asymptote, that means that the function, whatever it's doing anywhere else, and as a bonus point, y is what I've sketched, not a function. But whatever the function is doing anywhere else, at the asymptote it's not defined, so the equation of the vertical asymptote is when x is equal to 1. Because we can see from the function that that's the point where the function is not defined. Watch out, because it asks for an equation, so you must give x equals 1 as the equation of the asymptote. You must not write x is not equal to 1. That's not an equation. It's technically an inequality because it's using one of the inequality signs. And that's not the asymptote. The asymptote is the line, and the line has an equation, x equals 1. So, don't do that. That's wrong. Part 3, I've labelled these wrong, look. That's part 1, that's part 2. Part 3 is find the equation of the horizontal asymptote. Well, the horizontal asymptote of a graph like this comes when you think about what happens as x goes off to infinity or goes off to negative infinity. So we've got f of x is equal to 2x minus 6 over x minus 1. What happens as x gets really, 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 really big or really, 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 really small is that this minus 6 and this minus 1 become inconsequential. So, as x tends to infinity, the limit of this function is equal to 2x over x, which is just 2. Which means the horizontal asymptote is x equals 2. And I've sort of preempted myself here because it asks what's the limit as x tends to infinity of the function f. Well, I've already answered that question. They're the same thing. The limit of f as x tends to infinity is the same as the horizontal asymptote. So the answer to part B is that the limit is 2 as well.